So I'm continuing my video session for O-level past papers, and I was doing 5070. This time I've selected paper 22. It's of May, June 2025. It's papers. It's theory. Total time is 1 hour 45 minutes. I'm not doing the details of other things like instructions and information. You all are aware that calculator is allowed. Total mark is 80. Priority will is printed in the question paper. So let's start the paper. Here's question number 1. Choose from the following salts to answer the questions. Here's a list of some salt. We have aluminum sulfate, barium chloride, copper 2 nitrate, copper 2 sulfate, magnesium chloride, potassium iodide, potassium magnate 7, silver chloride, sodium bromide. Each salt can be used once, more than once, or not at all. State which salt is prepared using a precipitation reaction. Recall precipitation reaction. This is used to prepare insoluble salts. To prepare insoluble salts. So you have to look for the salt that is insoluble in water and can be prepared using this method. If you look at the list carefully, you'll find silver chloride, the one which is insoluble according to the information for the solubility of salts from SLOs. So it should be silver chloride. So I will write silver chloride. B gives a yellow flame test color. Now this is something which you have to learn by heart. Now yellow flame test color is of sodium ions. This is a test for the sodium ions. And if you look at the list, you will find sodium bromide in the list. So you'll write sodium bromide as its answer. Part 3, dissolves to form a dark purple aqueous solution. You know that potassium magnates were purple color crystals. So it will form dark purple solution. So we'll write potassium magnate 7. Part D, has an aqueous solution that reacts with dilute sulfuric acid to give a white precipitate. Now, sulfuric acid is giving a white precipitate. It must be reaction between the Ba plus ion plus 2 ions to form white precipitate of BaSO4, that's barium sulfate. So you must look for the barium salt, soluble barium salt present in the list, and I will find it here. That's barium chloride. So barium chloride, it must be reacting with sulfuric acid to form this white precipitate of barium sulfate. So I will write barium chloride. E has an aqueous solution that reacts with aqueous bromine. Now this indicates the halogen group. In halogen, if you look at the group, here's group number 7. So halogen, fluorine, chlorine, bromine, iodine, astatine. If you go down the series, the reactivity decreases, which means the halogen at the top will be able to displace the halogen from its compound below it. So bromine, it must be reacting the salt of iodine, as iodine is below bromine. So potassium iodide must be the right answer in this case. Potassium iodide. Question number 2. A dilute aqueous solution of magnesium chloride is electrolyzed using graphite electrodes. A, graphite has a high melting point and is inert. Number 1. Explain why graphite has a high melting point. Use ideas about structure and bonding. Now they are asking in terms of its structure and bonding that why graphite has a high melting point. So for the structure, you straight away write it's giant covalent. Graphite is an allotrope of carbon which has giant covalent structure. So giant covalent will give you 1 mark. And Then you are going to write about bonding. Contains strong or many covalent bonds. Strong. Let me correct this. Giant covalent. So here, strong or many covalent bonds. You can write high amount of energy needed to break down. High amount of energy needed. Part 2. State one other property of graphite that makes it suitable for use as an electrode during electrolysis. So a substance to be used as electrode must be having free or moving electrons. So they are talking about the property. So it must be having electrical conductivity. It must be having electrical conductivity. So I will write high electrical conductivity in this case. High electrical conductivity. Part B. Predict the products of the electrolysis of dilute aqueous magnesium chloride with graphite electrodes. So now you are having dilute magnesium chloride. So what you will get? You will get hydrogen at cathode and oxygen at anode. So either you can write the formula or the name, because they are asking about to predict. They're not saying that write down the name of formula. Anode, you have O2 or oxygen. For cathode, you either have H2 or hydrogen. Part C. Molten aluminum oxide is electrolyzed using graphite electrodes to form oxygen and aluminium. Construct the ionic half equation for the reaction at each electrode. Now I am electrolyzing molten aluminum oxide and graphite electrodes used. So at anode, you will be getting oxygen gas. Write down the reaction for oxygen gas. It is oxidation, that is loss of electron. So O, molten state, O minus 2, FL. It will lose electron. You know that oxygen exists in the diatomic state, that's O2. And it must be in the gas form, gas state. Plus, there will be loss of electron. Let's balance the equation. 2 multiplied by 2 is 4. So 4 moles of electrons will be lost at anode. For what cathode? Aluminum will be carrying +3 charge. If you look at the position of aluminum, here's aluminum. It's in group 3, so which means it must be having have lost 3 electrons in this aluminum oxide. So it needs 3 moles of electrons to form aluminum, molten aluminum. So Al will be produced at cathode. The metal object is electroplated with copper. The metal object is the cathode during this electrolysis. State the name of the substance used for the anode and for the electrolyte. Now I want to electroplate an object with copper. So anode must be of copper. For the electrolyte, you can have salt or aqueous solution of copper, like copper 2 sulfate or copper 2 nitrate. Aqueous solution of copper or copper 2 nitrate or copper 2 sulfate. You can write any one of these.
Welcome to Chain of Qualified Tutors. Unlock your academic potential with expert tutoring, from secondary school to graduation level. Master math, science, English, and more with personalized one-on-one guidance. Call or WhatsApp for a free demo session. We offer on-site and online tuition.
Question number 3. The equation for the reaction between ethene and bromine is shown in figure 3.1. So here's the reaction equation for the reaction between ethene and bromine. This is ethene. Bromine. And what we are getting dibromo ethane. Describe the observation when ethene gas is bubbled through aqueous bromine. Aqueous bromine is orange or reddish brown or yellow in color. So it goes to colorless. So I'm right, orange to colorless. Part B. Table 3.1 shows some bond energies. Here's a list of bond energies for some bonds at CH, CC, C double bond C, BR, BR, CBR. Show by calculation that the enthalpy change of the reaction between ethene and bromine, delta H, is minus 107 kg per mole. If you look at the reaction equation, what bonds are broken here? We have C double bond C, that's this bond is broken, BR is broken. And what bonds are made? CC bond is made and two CBR bonds they are made. So we know the equation. In order to find the delta H, energy change for bonds broken minus energy change when bonds are made. So I've already mentioned that C double bond C is broken and BR bond is broken. So I'm going to write C double bond C here plus BR. These are the bonds that are broken minus we have CC bond that is made plus two CBR bonds. Now putting the values of these. So C double bond C 610 plus we have BR 193 minus CC bond it's 350 and plus 2 multiplied by CBR which is 280. So if you solve this, what you will get? You will get 803 here minus 910. Subtract this. What you will get? You will get minus 107 kilojoules per mole. So this will be the final answer for this one. Part C. Complete the reaction pathway diagram in figure 3.2 for the reaction between ethene and bromine. Label the reactants, product, enthalpy change of the reaction, delta H, activation energy EA. So they have given us the axis, progress of reaction on x-axis and energy on the y-axis. If you look at the reaction, looking at this value, it's minus, which means it's exothermic. So product must be at the lower energy state than the reactant. So if we have reactant line here, then this must be of the product, low energy state. There must be energy hump between these two, like this. Now for the reactants, you can write down the formula of the reactants here. And formula of products on the right hand side. For activation energy, the hump is going up. So it must be activation energy going up. This indicates activation energy, EA. What about enthalpy change of the reaction, which is delta H? Arrow must be going down. So it must be like this, delta H. This will be the final reaction pathway diagram for this reaction. D, draw a dot and cross diagram to show the electronic configuration in a molecule of ethene. Show only the outer shell electrons. For your convenience, what I'm going to do, I'm going to draw the display formula of ethene on the right hand side. So this is ethene here, C double bond C, and we have H here. Remember to show key on the right hand side of the screen. We have space on the right hand side, so we have key. I'm taking dots for carbon and cross for hydrogen. So we have two carbon atoms, both are forming double bonds. So two electrons will be coming from each carbon atom. For instance, on the right, for the right hand side, We have 1, 2, 3, 4. For the left hand side, 1, 2, 3, 4. Now for the hydrogen, we have 4 hydrogen atoms. Various electron for hydrogen atoms will be shown using cross for this hydrogen, this hydrogen, this hydrogen, and this hydrogen. So this will be the final dot and cross diagram for each link. Question number 4. Ethanoic acid CH3COOH is a member of the homologous series of carboxylic acid. Give the general formula of the homologous series of carboxylic acid. This is something which you have to learn by heart. It's CnH2n plus 1 COOH. Part B. One characteristic of a homologous series is that all the compounds share similar chemical properties. Explain why the compounds share similar chemical properties. Because they all have same functional group. You know that the functional group, it governs the chemical properties of the compound. So yeah, they have same functional group. Part C. The equation for the reaction between calcium and dilute ethanoic acid is shown. Here is the reaction. Ca plus 2 CH3COOH gives H2 plus CH3COO whole twice. 1. State the name of the compound CaCH3COO whole twice. You know, this is a salt of carboxylic acid. Here, it's ethanoic acid. And carboxylic acid gives alkanoate ion. So whatever metal is there, that name comes before that alkanoate ion. So in this case, we are having ethanoate. So what you are going to write? You write calcium ethanoate. Calcium ethanoate will be the name of the compound. Calcium ethanoate. Part 2. A sample of 1.35 gram of calcium is added to excess dilute ethanoic acid. Calculate the volume of hydrogen formed measured at room temperature and pressure. Give your answer to 2 significant figures. Now they gave us the mass of calcium and they are asking us to calculate the volume of hydrogen produced. If you look at the relation for calcium and hydrogen, it's 1:1. So 1 mole producing 1 mole. So if we have the moles of calcium, you can easily calculate the moles of hydrogen. So first of all, I'm going to convert mass of calcium into moles. You know the formula? Mass divided by AR. Here's calcium. Here's calcium. 40 will be taken as its mass. So calcium 1.35 divided by 40. What we will get? We will get 0.003375 moles. So if 1 mole produces 1 mole of H2, so it's not 0.00, it's 0.03375. So 0.03375 moles also gives 0.03375 moles of hydrogen. Now we have the moles of hydrogen. Just convert this into volume. The answer, it must be in dm cube. You know that 1 mole of any gas, it occupies of a gas at RTP. RTP is room temperature pressure, occupies a volume of 24 dm cube. So what we are going to do is simply multiply it by the moles in order to get the volume of H2 hydrogen gas. So what you will get? 0.03375 0.75 into 24. So answer is 0.81 TMQ. D. Dilute ethanoic acid is a component of vinegar. Describe the manufacture of vinegar. Include the reactants and conditions. So ethanoic acid can be made from the oxidation of ethanol, which takes place in air and in the presence of bacteria. So reactant must be ethanol and oxygen. Ethanol and oxygen. This is the reactant. For the condition, ethanol and oxygen, air, and presence of bacteria. Moving to next part, this is part E. Butanoic acid and propanoic acid are two other carboxylic acids. One, state the molecular formula of butanoic acid. So butanoic acid, it must be having 4 carbon in all atoms. So for this, N must be 3. For your convenience, I'm writing the general formula of carboxylic acid, which is CN H2N plus 1 COOH. You see some COOH is there, which means 1 carbon is already there. You need 3 more carbon atoms in order to get the molecular formula of butanoic acid. So for N, I'll be taking 3. So C3 H2 multiplied by 3 is 6. 6 plus 1, 7. H7 COOH. So it must be C3 H7 COOH. Or you can even write down in this way, C4, count all the atoms, H8O2. 2. Draw the display formula of propanoic acid. Propanoic acid. For the propanoic acid, we know it must be having 3 carbon atoms. So N must be 2 here, not 3, 2. Using this general formula, predict the molecular formula of propanoic acid first. It must be C2H5COOH. Now we need to draw the display formula of propanoic acid. You know, the carboxylic acid, they must be having functional group COOH. So we have 3 carbon atoms in total. 1, 2, 3. Third carbon atom, it must be having carboxylic group. That's double bond. I'm showing this carboxyl group. C double bond O, single bond O, O single bond H. Now, for the other carbon atoms, show bonding with hydrogen. 1, 2, 3, 4, 5. This will be C2H5. So this will be the final displayed formula of propanoic acid. Part 3. Solid sodium carbonate is added to dilute propanoic acid. Predict an observation for this reaction. Now, this one is metal carbonate. Metal carbonate. And you are adding it to acid. This one is acid plus acid. So what you will get? Whenever you react metal carbonate with acid, you will get metal salt, hydrogen, metal salt, water, and carbon dioxide. Due to the presence of carbon dioxide gas, there will be effervescence, fizzing or bubbling. So you're going to write effervescence, fizzing, or bubbling. Part 4. Aqueous sodium hydroxide is added to dilute butanoic acid. State the names of the products of this reaction. Now this one is alkali. This one is acid. What you get when you react acid with alkali? You will get salt plus water. So one of the product must be water. What about the salt? For the salt, you will get metal alkanoate, and we'll be getting alkanoate from butanoic. It must be butanoate. Metal is sodium. So you'll be getting sodium butanoate. and sodium butanoate. This will be the salt produced beside water. Moving to next question, which is question number 5. The combustion of fossil fuels is used in some power stations. A. Some power stations use diesel oil as a fuel. Part 1. One compound in diesel oil has the formula C12H26. Construct the symbol equation to show the complete combustion of C12H26. You know, in combustion reactions, we react these organic compounds with oxygen. And we also know that in complete combustion reaction, what we will get? We will get carbon dioxide and steam or water as the other product. So you need to balance this equation. So in order to balance this equation, we have 12 atoms of carbon on the reactant side. So it must be having 12 moles of carbon dioxide. What about hydrogen? 26 atoms of hydrogen on the reactant side. So I need to write 13 before H2O in order to balance hydrogen. What about oxygen? On the product side, 12 multiplied by 2 is 24. 24 plus 13. What you will get? 7. 2 plus 1 is 3. 37. 37 atoms of oxygen. We have O2 here. So 18, half. You have 18, half O2. Now this reaction is balanced, completely balanced. 2. The complete combustion of C12H26 produces an air pollutant. State one adverse effect of this pollutant. Air must be talking about this pollutant. Because in the complete combustion, we are getting carbon dioxide. This carbon dioxide is responsible for global warming. So you can write global warming. And this global warming is responsible for some climate changes. So you can even write climate change if you want. Part 3, explain how diesel oil is separated from petroleum. Now they are asking the process to obtain diesel oil from petroleum. So you know that crude oil or petroleum is also crude oil. Crude oil or petroleum, it's heated to 400 degrees centigrade. Petroleum is heated to 400 degrees centigrade. Now it's of 3 marks. So you can mention 3 points. This will be the first point. Second point must be use of fractional distillation. Use of fractional distillation. Do not write outside this line. Stay inside this line, whatever you want to write. The use of this fraction distillation. So the fraction that will be separated on the basis of difference in the boiling point. So you write fraction separated on the basis of difference in the boiling point. What else you can write? Diesel will be collected according to its boiling point. Or you can even write diesel will be collected according to its boiling point. For the best answer, what I'm going to do, I'm going to choose these. So petroleum heated, use of fraction distillation, and this diesel will be collected according to its boiling point. This must be the best answer for this one in order to gain full 3 marks. Part B, sulfur dioxide is removed from the emissions from a power station using calcium carbonate powder. Stage 1, adverse effect of sulfur dioxide as an air pollutant. Sulfur dioxide, it's an acidic oxide. So acidic oxide, they are responsible, you know that, for acid rain. Part 2. 1 mole of sulfur dioxide reacts with 1 mole of calcium carbonate to make 1 mole of carbon dioxide and only one other product. Suggest the formula of this product. So if I will write the formula, we have sulfur dioxide, this is SO2, calcium carbonate, you know the formula of calcium carbonate, it's very easy, CaCO3. And they have already mentioned they are reacting in 1:1 mole ratio. So the product is 1 mole of carbon dioxide. So 1 mole of carbon dioxide and one other product. So if you remove CO2 from CaCO3, what will you get? You will get CaCO2. So here we are having metal. Only oxygen is left. CaO is left in this. CO2 is gone. So you'll get metal salt. So it must be between calcium and one oxygen is left, you will be having SO3. SO3 is the sulfide ion, and sulfide ion is carries -2 charge. You know, calcium, where is calcium? Here's calcium. It's in group 2, which means valence is +2. So I will write calcium here, +2. Note the charges. These subscripts, they are same subscripts. These will be simplified 1:1. So what you will get? CaSO3 plus CaSO3. So CaSO3 must be the formula of the other product obtained here. Part 3, state and explain the effect of increasing the temperature on the rate of this reaction. Now they are asking about the rate. So this question is of 2 marks. You're not going to gain mark for the statement, but this statement is very important, that you have to write the effect of increasing the temperature on the rate of reaction. So what will happen to the rate of reaction? Rate of reaction increases. Rate of reaction increases. This must be the first statement. It should be there. So you will not get any mark unless 2 more statements. You have to write 2 more statements, and you can write in terms of energy or movement of particles. First statement, in terms of energy or movement of particles. Like you have particles having high energy. Particles have high kinetic energy or high energy. Have high kinetic energy or energy. Or particles move faster. Other statement, what you have to do, refer to the collision. In terms of collision between particles, refer to collision between particles. What you are going to write? You will write more effective or successful collision. More effective or successful collisions. You can even refer to the percent or ratio or proportion of particles having energy equal to or higher than activation energy, or refer to the percentage ratio or proportion of particles having energy equal to or higher than EA. EA is activation energy. So any two from these, any two from these, then you will be able to get full marks in this question. Part 4, lumps of calcium carbonate are used instead of calcium carbonate powder. State and explain the effect of change on the rate of reaction. Again, this is of 2 marks. You are not going to gain mark for the statement, only statement for the rate of reaction. So first of all, you're going to write what will be the effect. If you're using the lump means large size. If you compare lump with the powder form, lump is large size particle. So rate of reaction decreases. So you write rate decreases. Then any two from. So any two statements like in terms of particles exposed, in terms of particles exposed, like you have in case of lump or large size, you have fewer particles exposed, fewer particles exposed, or in terms of surface area to volume ratio, in terms of surface area to volume ratio. So you have decreased surface area, decreased surface area, or you can write in terms of collision frequency, in terms of collision frequency. So what you're going to write, less frequent collisions, less frequent collisions, or less collisions per second. So you can write any two of these statements in order to gain full 2 marks. Question number 6. Bromine Br2 is in group 7 of the periodic table. A. The melting point of bromine is -7 degrees centigrade and the boiling point is 59 degrees centigrade. 1. Explain why bromine is a solid at -50 degrees centigrade. Simply what you have to do, refer the melting point of bromine. -50, it's lower than melting point. -50 degrees centigrade is lower than melting point. So you can write the melting point of bromine. Number 2, describe the arrangement and motion of bromine particles, molecules at -50 degrees centigrade. Now this question is of 3 marks, so you have to write 3 points. Now they are asking about the arrangement and motion of particles. So for the arrangement, we will talk about the pattern and packing of the particles. So for the arrangement, what I'm going to write, I will write particles are in a pattern and closely packed together. Particles are in a pattern and closely packed together. What about the motion of the particle? Now see the state of bromine molecules at -50 degrees centigrade. -50 degrees centigrade is lower than melting point, which means that it's in the solid state. So you have to write the motion of the molecules in the solid state, which is vibrate about fixed position. Vibrate about their fixed positions. Moving to next part, which is part B. A sample of bromine liquid contains 2.408 into 10 to the power 25 molecules. 1 mole of bromine liquid contains 6.02 into 10 to the power 23 molecules. Calculate the mass of this sample of bromine liquid. Now, the molecules of the bromine liquid, it's given, and we all know that 1 mole contains the Avogadro number, which is also provided here. So what you need to do, you simply have to divide the molecules by the Avogadro number in order to get the moles. So for moles, what I'm going to do is divide this 2.408 multiplied by 10 to the power 25 divided by 6.02 into 10 to the power 23. So the moles for this one will be 40 moles. Now, in order to calculate the mass, we need to multiply the moles by the MR. Bromine, we know that bromine exists in the Br2 form. Here's bromine in the periodic table. It's in group 7, you see. The nuclear number of mass of this bromine element is 80. So 80 will be multiplied by 2. We'll get 160. So in order to get the mass, you need to multiply moles by the MR. Mass is equal to 40 multiplied by MR Br2. So you have 40 multiplied by 160. What you will get? You will get 6,400 grams. This will be the final answer. Part C. The ionic equation shows the reaction of bromine with warm concentrated aqueous sodium hydroxide. This is the reaction equation. 3 moles of Br2 plus 6 moles of OH negative gives BrO3 minus plus 5 moles of Br minus plus 3 moles of H2O. One, state the oxidation number of bromine in Br2 and in Br minus. Now Br2, it's not carrying any charge. If an element is not carrying any charge either in the atomic state or the molecular state, so the oxidation number must be 0. So I will write 0 for Br2. What about Br minus? Minus will be the oxidation number of this one. So I will write -1. During the reaction, bromine is reduced. Explain why using ideas about electrons. You see, Br2, it's reduced to Br minus. You see the charge on Br? It's carrying minus charge, which means it has gained electrons. So you will write bromine gains electrons. D. Bromine reacts with hydrogen in a closed system to form an equilibrium mixture. The forward reaction releases thermal energy into the surroundings. If the forward reaction releases thermal energy into the surroundings, it means that the delta H must be minus for the forward reaction. 1. The temperature of the equilibrium mixture is increased. The pressure remains constant. State and explain what happens to the position of the equilibrium. You see, if you have increased the temperature, the direction of the equilibrium will shift to the endothermic side. So if the forward reaction releases energy, which means it's exothermic, then backward reaction must be endothermic, which means delta H is positive for the backward reaction. So equilibrium will shift to the left hand side or reactant side. So moves or shifts to left hand side. Explanation, you can refer to the refer whether the forward reaction is exothermic or backward reaction is endothermic. Refer either forward reaction is exothermic or backward reaction is endothermic. Part 2. The pressure of the equilibrium mixture is increased, the temperature remains constant. State and explain what happens to the position of equilibrium. Remember, the effect of pressure is only applicable to gases. So we have gases on both sides of the equation. If you look at the equation, we have 1 mole of Br2 plus 1 mole of H2 to produce 2 moles of HBr. So refer to the number of moles or molecules or even volume of gases on both sides of the equation. So you see there are equal number of moles, molecules or volume of gases. So what will be the effect? So you write no effect or no change. No effect or no change. For the explanation, refer to the moles, molecules or volume of gases. Refer to the moles or molecules or volume of gases on both sides of the equation. Both sides of the equation. You can write, yeah, same moles, same molecules, same volume of gases. Part E, a bromide of phosphorus contains 7.2% phosphorus by mass. Calculate the empirical formula. This bromide. Now, this is a bromide of phosphorus, which means it contains element phosphorus and bromine. The percentage of phosphorus is given, which is 7.2%. For bromine, what I'm going to do, I will subtract 7.2 from 100. The answer will be 92.8. The first step, what you have to do? Divided by the nucleon number of mass of these elements. So phosphorus, where's phosphorus? Here's phosphorus. You see, the mass or nucleon number of phosphorus is 31. Bromine, it's 80. So in the first step, 7.2 divided by 31 for phosphorus, and for bromine, 92.8 divided by 80. So what you will get? You will get 0.232 for phosphorus and 1.16 for bromine. 0.232 is the least value in this case. So I will divide both these values by 0.232. What you will get? You will get 1 for phosphorus and 5 for Br. So my empirical formula will be PBr5. Number 7. Iron is used to make stainless steel. Stainless steel is used to make cutlery because it is resistant to rusting. Give one other reason why stainless steel is used to make cutlery. Definitely, it must be hard. This must be the property that keeps it intact. Besides resistant to rusting. Part B. Stainless steel is an alloy. Give the meaning of the term alloy. Alloy is a mixture. So mixture of metal with other element. For other element, you can either have non-metals or metals. So mixture of metals with other elements. You can either have non-metals or metals or both. Part C, iron nails are galvanized with zinc to prevent rusting. Explain 2 ways in which galvanizing iron nails with zinc prevents rusting. If you look at the position of zinc in comparison to iron, you see that zinc is above iron, so it forms a barrier or protective layer. And that barrier or protective layer prevents oxygen or water reaching surface of iron. Why? Because zinc is more reactive than iron, or zinc corrodes or oxidizes in preference to iron. Now, this question is of 3 marks, so you have to write 3 statements. So first of all, you can write zinc forms a barrier or protective layer. Then you will talk about that layer. That layer of barrier prevent layer prevent oxygen or water reaching surface of iron. Last statement, you can either write zinc more reactive than iron, or zinc corrodes or oxidizes in reference to iron. Part D. Iron reacts with hot dilute sulfuric acid to form hydrogen and aqueous iron-free sulfate as the only products. Construct a simple equation for this reaction. Now, iron, formula for iron is Fe, so you write Fe. And they are saying state symbols. Iron is a metal. It must be existing in the solid state, so I will use S for iron. Plus, it's reacting with hot dilute sulfuric acid. The formula for sulfuric acid is H2SO4. It must be aqueous. So I'm using AQ for aqueous. For the products, they are saying hydrogen is produced. Formula for hydrogen is H2. Hydrogen exists in the gas state, so I will use G for hydrogen. What about the formula for aqueous iron 3 sulfate? Iron is carrying +3 as its oxidation number, and you know the charge on sulfate ion is -2. Ignore these charges. These subscripts will be exchanged. So what you will get? You will get Fe2SO4 whole thrice. Fe2SO4 whole thrice. So it's aqueous. So I'm using AQ for this one. So now let's balance this equation. Let's balance iron on both sides. So we have Fe2SO4 whole thrice. So I will write 2 before Fe, solid. What about H2SO4? You see, we have 3 sulfate ions. So I am placing 3 before H2SO4. SO4 is balanced. Place 3 before H2 gas. Now this equation is balanced. Question number 8. Figure 8.1 shows the displayed formula of compound A. Here's figure 8.1 for the compound A. Compound A is both a saturated alcohol and a saturated ester. Explain why compound A is saturated. If you look at this displayed formula, you will see it contains only carbon-carbon single bond. So you write all carbon-carbon bonds are single. All carbon-carbon bonds are single. Remember, you have to refer to the carbon-carbon bonds when we are talking about saturation in organic compound. And this structure is of organic compound. Part 2. Explain why compound A is an alcohol. If you look at the displayed formula, you will see OH is there. So it contains hydroxyl or OH functional group. Contains hydroxyl or O bond H functional group. So part 3, explain why compound A is an ester. So it contains ester linkage. Contains ester linkage. This is ester linkage. See double bond O linkage. So you write like this. B. Figure 8.2 shows compound B. Explain why compound A and compound B are a pair of structural isomers. You know the definition of structural isomer. They have same molecular formula but different structures or structural formula. So first of all, I'm going to write the definition. Same molecular formula and different structures or structural formula. Now let's see. Are these having same molecular formula? How many carbons are there? 1, 2, 3, 4. 4 carbon for this one. What about hydrogen? 1, 2, 3, 4, 5, 6, 7, 8. H8. Oxygen. 1, 2, 3. O3. So this will be the formula for compound B, C4H8O3. Let's check compound A. How many carbon? 1, 2, 3. C3. How many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8. H8. What about oxygen? 1, 2, 3. O3. That's why, sorry, there must be 4 carbons. I missed this one. This C4H8O. So that's why it's structural isomers. Both of these are isomers. C, the displaced formula of compound C is shown in figure 8.3. Compound C is an ester. It's containing this functional group. That's why it's an ester. Compound C is made by the reaction of an alcohol and a carboxylic acid in the presence of a catalyst. State the name of the type of catalyst used in this reaction. So we have acidic catalyst used. So I'm going to write acidic. 2, state the name and draw the displaced formula of the alcohol used in this reaction. If you look at this carefully, so it must be having this alkyl group coming from alcohol. Alkyl group coming from alcohol. So we must be having alcohol with 3 carbon. So it must be propanol. So you have to mention the position of OH in propanol because there are 3 carbon atoms. So you'll write propane 1-ol. Propane dash 1-ol. Now I need to draw the displaced formula of propane 1-ol. So we have 3 carbon for propane. 1, 2, 3. Now let's saturate the carbon atoms. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now let's place OH. Hydrogen will be left. So this will be the final displaced formula for propane 1-ol. D. Figure 8.4 shows 2 monomers that react to make a condensation polymer. Part 1, draw the structure of 1 repeat unit of this condensation polymer. You know that during condensation polymerization, a molecule of water is released. So if you look at these, you can either remove OH from this side or OH from this side for both of these molecules. And then we need to remove H from one of these. Then whatever we'll get, that will be the polymer, condensation polymer of these two. So I'm removing hydrogen for these. That's monomer D and OH from monomer E. What I will get? I will get this. 1 repeat unit will be like this. Remember, O will be joined with this C double bond O. And we have 3 carbon carbon atoms. 1, 2, 3. Last one will be shown like this. So this will be the 1 repeat unit for the polymer obtained. In fact, condensation polymer obtained. Part 2. An equal number of moles of the monomers D and E are reacted to make the condensation polymer. The total mass of the monomers D and E is 80 gram. There is a 100% yield. Explain why the mass of the condensation polymer made is less than 80 gram. Definitely you are getting one more product, that is water in this case. So you can write polymer and water are made. Polymer and water are made in this case. So you can write one more product obtained.